Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rohini College of Engineering and Technology. I am going to handle the subject on transmission lines and RF system. So in Unit 3, I am going to discuss about the topic on the 8 wave line. So this will be also called as lambda by 8 line. 8 wave line. The students will be able to know about what is meant by 8 wave line. Write the expression for the 8 wave line. What is meant by 8 wave line? So basically in the transmission lines is used to transmit the power from source to the load. So due to that the maximum power will be transmitted by the transmission line to the load with the minimum losses, and then there is no reflected wave will be present. Otherwise the impedance will be equal to the characteristic impedance of the transmission line. So due to that the load will be properly matched, so such that this condition is not achieved. So due to that the transmission line has the impedance matching technique based on the short length transmission lines lambda by 2, lambda by 4 and lambda by 8 line, and based on the stubs single step matching and double step matching. So the 8th wave line. So this is the diagram for the 8th wave line. So in this 8th wave line, the transmission line with a finite length has lambda by 8, and the input voltage and the current are denoted by ES and IS. Then the input impedance of the transmission line is given by Z in. Then the receiving end voltage and the current are denoted by ER and IR. Then the distance between the sending end to the receiving end will be S is equal to lambda by 8. Then already we know the input impedance of the distortionless line transmission line is given by, so that is Z in is otherwise called as ZS. So Z in will be equal to ES divided by IS, that is sending end voltage divided by sending end current. That will be equal to R naught into ZR plus J R naught tan beta S divided by R naught plus J ZR tan beta S. So next we are going to substitute S is equal to lambda by 8 and beta is equal to 2 pi divided by lambda in the above equation. So after substitution of this equation we will get Z in will be equal to R naught into ZR plus J R naught tan 2 pi divided by lambda into lambda by 8 in divided by R naught plus J ZR tan 2 pi divided by lambda into lambda by 8. So after that the lambda will be cancelled, then 2 divided by 8 will be cancelled, then remaining will be 1 by 4. So after we will get the equation as Z in will be equal to R naught into ZR plus J R naught tan pi by 4 divided by R naught plus J ZR tan pi by 4. Then for tan pi by 4 we will substitute as 1. So after that we will get the equation as Z in will be equal to R naught into ZR plus J R naught divided by R naught plus J ZR. Then we are substituting the modulus on the both the side. So after that we will get the equation as Z in will be equal to modulus of R naught into modulus of R naught plus J R naught divided by modulus of R naught plus J modulus of ZR. Then after that, for example, modulus of A plus JB will be equal to root of A square plus B square. So the same condition will be applied in the equation. So the answer will be Z in, that is modulus of Z in will be equal to R naught into root of R naught square plus ZR square divided by R naught square plus ZR square. Then the both the root term will be cancelled. After that we will get the answer as modulus of Z in will be equal to R naught. So thus the eighth wave line is commonly used to transformer any that having any resistance ZR with an impedance Z in having its magnitude will be equal to the characteristic resistance R naught of the transmission line. Based on 8 wave line, which transmission line is called as 1-to-1 transformer?